Brad Williams, Frugal Finance. We're revisiting session 3, interest rate swap pricing. The term structure of interest rates is the key to pricing interest rate swaps. The term structure of interest rates and the term structure of foreign exchange rates are the keys to pricing currency swaps. We have seen that bonds, forward rate notes, forward rate agreements, calls and puts on SOFR, foreign exchange forward contracts, interest rate futures and swaps are all related instruments. If they're not priced properly relative to each other and relative to the existing term structure, arbitrage will be possible. Remember I said the circle? Well, here's the circle. Thus, we approach swap pricing in a no arbitrage environment that focuses on the term structure of interest and currency rates. The term structure of interest rates and foreign exchange rates. There are 3 related term structure or yield curves. We have the par yield curve, the zero coupon yield curve, and the implied forward yield curve. The par curve expresses the relationship between the yield on a coupon bond selling at par and bond maturity. The zero coupon yield curve shows a relationship between yield and maturity for single future payments. The implied yield curve shows a relationship between forward rates of interest for various future periods as implied by the par yield curve and the zero coupon yield curve. These 3 term structures form an integrated system. One set of rates implies another. For example, the zero coupon yield curve can be found by using the data of the par yield curve in conjunction with the techniques of bootstrapping as discussed below. Below are a few key notations related to bootstrapping. Z of X of Y, the zero coupon factor for an investment initiated at time X and extended until time Y. F of R, X of Y, forward rate of interest for a period beginning at time X and extending until time Y. F of R, A, X of Y, the interest rate on an FRA for a period beginning at time X and extending until time Y. FR of F, the forward rate factor for a period beginning at time X and extending until time Y. We also note the following. F of R of X of Y is equal to FRA X of Y equals F of R FRF X of Y minus 1. FRF X of Y is equal to ZO of Y divided by ZO of X. To illustrate Treasury instruments par A, B, C, D, we have maturities 1 month out to 3 years. Here's the coupon, here's the price. Cash flow from Treasury bonds, 2.9 equals D28, 5.8, divide this by 2. D29, 6%, divide this by 3. Clearly, these are semi-annual. Here's the cash flow. Cash flow years. We're going to get 100, cash flow 1, cash flow 100, cash flow 100, 0, 100, 100.46, 7.12, cash flow for years. Cash flow from Treasury bonds, it's just this rate divided by 2. Don't worry about this. This is just me making some notations. The first task is to find the 6-month zero coupon. 6 months, 1 year, 1.5, 2, 3. This is going to be based off of our equation 100, 102.9, Z05. Here's our price, 100.29 divided by Z. Then we're going to have the rest of the notations, 109 divided by 102.95. That's 102.9. Now then the 1 year is going to be 3% divided by Z0. plus 103, which is going to be, you're going to get your $100 plus the dividend. First 6 months, second 6 months. Year and a half, we're going to go 3.2 divided by 1.29 plus 3.2 divided by 1.06931 plus 103.2 divided by Z0 1.5 and so on and so forth. And I'll explain to you where the 1.0639 comes from in a second. We have this layout, this format, and now Bootstrap zero rate coupon factor, 1.029 divided by 100. Forward rate, this is our start rate. The forward rate is going to be B53 divided by B52. That's our forward rate. Then we're going to go and we're going to continue doing this. Our forward rate, 106,931 is going to be 103 divided by 100 minus 3 divided by 1.029, exactly as the formula shows. You're going to plug this in to this formula. It's going to show 1.609. Then you're going to use this to compute the zero rate. Now that's here, here, here. Here we have B54 divided by B52. So we have this divided by this. So now we have the forward rate 1 year factor. And then we have forward rate 1.5 year factor. Then we have annual yield, continuous compounding. So our starting point is here, right here. We're looking at determining the zero coupon factor based on these cash flows. Don't worry about this information here. It's not relevant. We have our annual coupons. We're taking this information and dividing by 2. From there, we're going to determine the zero coupons. And here's just the math laid out, kind of quirky. If you follow it step by step, you'll get this end result here, and it's the formula. It's the formula as noted above. You just need to extend this thing for each series. 6 months, you're going to take 109, divide this by Z0 of 5. So you have 100 equals 109, and you're going to solve for Z0 of 5. In the end, here's the number, and you're going to do it sequentially. Going to go down, look at the numbers, okay? Look at this formula right here, 100. Where's the 3? Well, we know that's the coupon. And then 1029 plus 103, Z. We've done this, but I'm going to explain it as we work through these. And here's the math. We're going to go 103 divided by 100 minus 3 divided by 1029. Remember, we're going to go forward and then back. So we're looking at the 103, which is this right here, 3%. 103, 100 minus 3 divided by 1029. That's this number here. Then we're going to go 3.2 divided by 3, okay? And we're going to do this series for each period. And eventually this formula is going to stretch out to cover 103, 3.5, 3.5, 3.5, and we're discounting each one of these J46, J46. So we're just going up here and we're discounting this. Here's our Bootstrap zero rate coupon factor. So we have our zero rates. You're going, so what, Brad? In order to compute the swap fixed rate, we have to determine this bootstrap. So now we have the Bootstrap zero rate. We also have the forward rate 6-month factor. We have the forward rate 1 year factor. We have the forward rate 1.5 year factor. Smush these all together, it looks so much easier. Our zero annual yield with continuous compounding, we've used this in the past. So if you need to go way, way back to present value, future values for continuous compounding, do so. So we're going to have this 5638 number, and then we're going to just use this information here for the annual coupon. Our swap fixed rate average is going to be right here. We're going to use this really cumbersome equation. So we're taking G52 right here, 5.8 divided by B52, the zero factor, plus G53 divided by B53. We're going to go through that and we're going to get this swap fixed average. All right, we're going to end up dividing this by 1 divided by B52, B53, B55. Got that? So now we have this 6.234. The next question is, what's this SFR rate? Well, the SFR rate has to equal the forward rate. Where's the 23.05855? Well, that's this 0.058 right here times 0.05 times 20 million, 20 million. Divide this by the zero rate plus 0.06 the next period times 0.05, 2 million. Divide this by 1.609 to 0, and you can continue this, and you're going to come up with this number. Then you're going to have this forward rate, which is 0.058 times 0.05. Divide this by 1.029 plus 0.06 times, etc. And then you're going to eventually divide this by this number here. Does it continue? No. So now you have this forward rate. So what's the difference between this rate, 0.62349, where's that 0.62349 coming from? That is our fixed rate average times point. I gave you the wrong, we were looking at the forward rate. Here's the SFR rate is this swap fixed rate average times 0.05, and you're going to go through this plug and chug. Then you're going to go through the forward rate, and you're going to plug and chug. And if they're not equal, then something doesn't match. It's time consuming. No ifs, ands, or buts. The geometric average, we don't use it. It's just to look to see if there's some consistency here. We talked about forward rates. This number, it was in the other example. That's why it's orange. It's just reference. So now the question is find the forward rate if you have the zero rate. So you have the zero rate right here, 1.029. Here, it's just a hypothetical situation. I was probably caught up. I was in the zone and I was looking at this, and you have this forward rate, the swap fixed rate. The question I probably posed was, well, what if I have the zero rate? What would be the forward rate? Ignore this right here, this 15063. And just think, you have a zero rate of 1.2475 for 6 months, 0 times 6. That's the equivalent of 495. That's the equivalent of this formula right here. But ignore it. All you have is the 1.2475. How would you find the forward rate? Well, here's the math. It doesn't mean anything. It may serve a purpose down the road for you, but just curiosity more than anything. It posed the question, and I had some help with an online service. It's SimLabs, I think. And I just plugged in the formula, got some assistance here because I was stuck somewhere here. I was this -1 and subtracting -1 from both sides. I was in a hurry or I was focusing on a million different things. But this will generate the forward rate for this particular zero. Is it important? Probably not, but it just goes to show you up here, it says you can go from one series to another to compute the other. Basic algebra, and that's all this is we're just solving for something else. But the point is, we can work through hypotheticals, and that's what this is. In regards to this number, it has to equal. If not, you're going to have to go back, and you see how meticulous this is. And even if you are black boxing it, and that's all this is a black box now, because you're going to just plug and chug. And I don't want you to plug and chug. I want you to make some mistakes. The swap fixed rate needs to equal the forward rate. Why? Well, don't say just because it's arbitrage. Look at the math. Look at the details. Look at the intricacy and look at the accuracy. In other words, all it takes is you're slightly distracted and you input the wrong number here. Well, guess what? It could be any number of these numbers. So when you do this, you just have to be, you have to be a good typist. With that being said, pricing a plain vanilla interest rate swap, we're going to continue on the subject. Pricing a plain vanilla interest rate swap In a plain vanilla interest rate swap, the received fixed party will pay a floating rate equal to SOFR flat in each period. Determining a price for the plain vanilla interest rate swap requires finding the fixed rate that will be received in exchange for making the sequence of floating rate payments. This is called the swap fixed rate, or the SFR. The time the swap is negotiated, the agreed SFR must not give an arbitrage opportunity to either side. This no arbitrage condition means that the agreed swap fixed rate must be consistent with the term structure of interest rates. One way of determining SFR is to use FRA quotation as representative of the term structure. This was given. We're working off that information along with this information which was given. This no arbitrage condition means that the agreed SFR must be consistent with the term structure of interest rates. One way to determine the SFR is to use FRA quotations as representative of the term structure. Based on these FRA quotations, we use the no arbitrage equivalence of the present value of the strip of FRAs and use the present value of the fixed payments to find the no arbitrage fixed rate for the swap that is consistent with the FRA quotations. In other words, we did this. We used all of this information in order to come up with this information. This is the present value. We begin by using an example of a plain vanilla interest rate swap with a notational principal of $20 million, a tenure of 2 years, and payments every 6 months. The following table shows the relevant quotations for a strip of FRAs and their associated payments with notional principals of $20 million. We have this 495 times 0.5 times 20 million, and so we have these numbers. Each payment on the fixed side would be the unknown swap fixed rate, SFR, times the half-year payment times the notional principal, 20 million. Each fixed payment would be SFR 0.5 times 20 million. With that, according to our no arbitrage principle, the sequence of fixed and floating payments must have the same present value of the initiation of the swap. We see that these rates range from 495 to 520. So it seems intuitively reasonable that the fixed rate must be in that range and that it should be some kind of average of these various floating rates. Recalling that ZO of t is the zero coupon factor for a horizon starting at the present time 0 and ending at time t, we will express time in months. So ZO18 is a zero coupon factor to cover the period from the present until the end of the 18th month. In our example, the no arbitrage conditions become 0.495 times half a year, 20, and so on and so forth until the 24th month. These rates, the 495, come from these forwards right here. Equation 21.9, in this no arbitrage condition, it appears that we have 4 unknown zero coupon factors: Z06, Z012, Z018, and Z024, plus the unknown swap fixed rate. However, we actually do have the information to find Z06, and we can use the Z06 to find the other factors through a technique known as bootstrapping, as shown above. Applying the bootstrapping technique, we can use an initially known zero coupon factor and forward rate to find successive factors. We illustrate the technique. For example, Z06 1 plus 0.5 times 0.0495 is equal to 1.2475. That is the zero for the first series. Whereas 0.5 reflects the half year between payments and 4.95 is the current SOFR spot rate. The factor for the second payment covers the first 12 months of the swap. Given the value of Z06, we can compute the value of Z of 12 is as follows. Z06 is equal to Z06 times 1 plus 0.5 times 0.05 equals 1.50369, where 0.5 reflects the half year between payments and 0.05 is the forward rate, right here, this forward rate. from the 6 by 12 FRA. Values for 18 and 24 follow similarly. Starting with the 0.6 and using the bootstrap technique, we have found all of the zero coupon factors that we need. We can now use these factors in equation 21.9 right back up here to find the swap rate. SFR is equal to 0.495 times 0.5 times 20 million divided by 1.2475 plus, and we're going to go on, and if we're lucky, here we have, well, there's more than one way to get this. All right. Here we're using a different technique, but just go with this, all right? I showed this, I think I showed this in the futures and zeros courses in section 3. I think I used this example, and here we're using a different example. We're using the swap fixed rate. We're using this average coupons right here, and this is a long drawn out process similar to what we're doing now. So we're using G52, which is these rates, G52 divided by B52. It's going to be the equivalent. We're going to use this swap fixed rate, and we're going to discount this back. This is going to be the annual rate. So there's some discounting here, and we're going to divide this by the zero coupon, which is similar to what we're doing below. In the end, we're going to get this swap rate, and then we're going to have this forward rate where we're using the coupon, the other information. We're doing the same thing, and there's a discounting going on here, and they equate and they equal the same. So with that being said, we'll just go with this example for simplicity. Here is the forward rate. We're going to go through, and here are the remaining forward rates. And starting with this particular formula, you can use this, you can crunch this number if you want. And the SFR is going to be 0.050598. This swap fixed rate of 5.598 is the rate on the fixed side if the swap that prevents arbitrage. We can generate this example using this. Off topic a little bit here, in that we were looking for this rates. Here it is right here, 495. We have a swap fixed rate of 5059, and here's the formula. I was using this to determine something else, but you're going to use C158, 495, divided by F158, which is going to be the number above. In the end, I was using this number here to equate this. We're going to use this 05598 here. See this? 05598 to come up with this SFR rate. And then we're going to use, for the forward rate, we're going to use the forward curve, the term structure, and they need to equal each other. I'm doing too many things because here is just another example. I didn't have the swap fixed rate. I just crunched a bunch of numbers. This is going to be the swap fixed rate using the average. You're going, Williams, what are you doing, man? Well, I'm showing you a bunch of alternatives. More than one way to compute this swap fixed rate. This is the average, and this is the other swap fixed rate using this formula. Which one works for you? Well, do what I did. Work out the numbers. That's the only way you do it. You're either passionate about this or you're not. If you're passionate about it, and I was when I did this initially a zillion years ago, I just get into the zone and you go, well, what if this or what if that? So why does this number equate to, and again, this is a different example. We're using different information, and then this topic here is a little bit different than above. In the end, it's going to equate and it's going to work out, and there will be no arbitrage situation. That's the goal here. No arbitrage. You can manipulate these numbers as long as they equal each other. There's not going to be an arbitrage opportunity. I know this is this is rather advanced, to say the least. Hopefully, I didn't put you off by bouncing around a little bit. I should have stayed on topic. I went off topic. I went through this first example, trying to determine this, and I just didn't pay attention. This is the swap fixed rate for this example. This is the swap fixed rate for this example. Work through them both. Brad Williams, Frugal Finance. Thanks for watching.